Hello. A while ago I picked up one of these ESP8266 development boards because I had a few people telling me in the comments that I should check these out because they're really cool. And when I found out that they are also really cheap, I thought, okay, I'll have a look and see what the fuss is all about. So what these are is a little microcontroller. You can see that one on the chip on the left says ESP8266. We can focus, kind of. But the cool thing about it is it also is Wi-Fi capable. So you can connect to the Wi-Fi access point in your house or at work or wherever you are, and you can send and receive data from servers on the internet or wherever the server happens to be, because the server could actually be another one of these, because this can also become a server to provide a service for other things on the network to connect to this. And you can see it also has a USB connection on there, so we don't need any annoying FTDI adapters or anything like that to get it to work. And this particular one has an external antenna connection there as well. So it's there's a few different sort of variants around, but this is the one I got. And so I got it and I checked it out and connected it up and played with a few basic sketches, and then I thought, what can I use this for? And I didn't really come up with any good ideas to use it for anything, so I just set it aside, and it's been collecting dust for about 6 months now. And just recently, though, I have eventually come up with some idea, of a good idea, which I can use this for. So to explain a little bit about what, here's the listing where I got it from Banggood, all sevens, lucky sevens. So it's pretty cheap considering it's actually quite a bit more capable than a regular Arduino, which is around about the same price. It has a lot more memory, and I think it's around 80 megahertz processing speed as well. So it's pretty good compared to an Arduino, at least. But recently I have finally set up quite a nice aerial video platform, and I've been thinking that I might try doing some aerial photography and uploading my photos to Drone Deploy, which is a site that lets you upload georeferenced images, and it will stitch them all together and make a nice sort of a Google Maps overlay to give you high definition photos of your area that you've flown over and surveyed. So that's why I did this survey planning, flight path planning thing. But the next step was to try and get the camera to trigger throughout the flight to take photos, but not just continuously on a timer. I kind of wanted to make it so that it would take photos every 20 meters or so based on a GPS location. And the other important thing is that you need to write into there'll usually be JPEG files, I think, because the JPEG file has a section in the file where you can write things like latitude and longitude, and altitude actually in this case as well, so that the Drone Deploy software knows where each of the photos should be in relation to each other. So you also need to make a record of the GPS location when you do this. And Drone Deploy seems to be set up mostly to use DJI software, or photos made by DJI drones like the Phantom and stuff, because they do this all quite automatically and very nicely for you, and they put the GPS data into the photo as well for you, so it's all very simple. But I'm using CleanFlight iNav, which doesn't do any of that stuff, not today anyway. So I wanted something that would basically click the shutter on my Xiaomi Yi camera and also make a note of where the GPS location was at the time that the shutter was clicked. And the first thing that I thought of to try doing this with was this thing here, which is a shutter. It's a Bluetooth shutter button. Basically, you just push the button and your Xiaomi Yi will take a photo. Or if you push this one, you can change it between video and photo. That will then start and stop recording a video. So I thought I'd get one of these, and this is just a rubber case here, but I thought I'd pull it apart and perhaps set up an Arduino connected to this with some sort of a mechanism to make this push the button when the Arduino says to push it, and then the GPS coordinates could be reading in by the Arduino as well. And then I could fly around and have my Arduino essentially pushing this button every time I've traveled, say, 20 meters from the last place the photo was taken, like that. So I got this and I sort of tried to pull it apart. It was a little bit difficult. And then along the way I discovered some other nice things about the Xiaomi Yi cameras. This applies to both the original Xiaomi Yi and also the 4K version that came out early last year. They both do this, but they're Wi-Fi enabled. So when you use your phone or your tablet to change the settings on your Xiaomi Yi, you're actually connecting over Wi-Fi, and the camera itself sets up a Wi-Fi network or access point, and you connect to that and then make some settings. Turns out you can actually use an Arduino or something else, not just a cell phone. As long as you send the right sort of data, you can do the same switching, and you can tell the camera to do this and that and read some settings off the camera and tell it to take photos and video. So that's what I've figured out how to do with the help of some internet searching and stuff. So let's have a look at the basics of how this system works on the Xiaomi Yi. I'm just going to put that aside for a minute because we can actually do it without that, and I like to, at least for myself, to figure out how things work. I like to do it manually first before I start writing an Arduino program to try and do it automatically, because that's a good way to see step by step how it works and figure out what it is you're actually trying to write your program to do. So let me just get my camera into the view and we'll see how this works. Okay, here's my Xiaomi Yi. I'm going to use the 4K Xiaomi Yi for this demonstration because it's a lot easier to do the setup on the screen here and show you what I'm doing, but it does work for the original Xiaomi Yi as well. It's in photo mode at the moment, but I don't think that really matters. I think it can be in video mode and it can still take still photos as long as you send it the right commands. But one thing you will have to do obviously is turn the Wi-Fi on. So you do that, so it's on, and then this will be opening a Wi-Fi access point. So in here, at the moment my computer is connected to my normal Wi-Fi router where I access the internet, so that's that IP address. But I'm going to have to disconnect from that one. I'm just doing this off screen, and I have to reconnect to the Xiaomi Yi. And it didn't show us on here, but the password by default is 12345678990. I think. Can we get it to show us that? Yeah, there we go. So yeah, if you change the password, obviously you'll probably know what the password is yourself, but that's what it is by default. So, and connect, and now we should see a different IP address, and it should be on this 42 subnet. That's good. And now we can telnet to a specific IP address on that network. 126.8.42. What is it? Hang on, let me consult my cheat sheet here. I forgot what the IP address is. Oh, it's 1, of course. And we need to use port 7878, which was where the server is running that will accept all these commands that we're going to give it. Alright, that works okay. You can do this on Windows as well, just a lot easier on Linux because all the stuff is already there. So now we're able to talk to a server that's running on here and give it commands and get some information from it. And I don't know how people figured this out, but just from looking around on the net, there's a handful of commands that people are aware of that they can use. Somebody sort of figured this out, some very clever people. And I have those over here. Basically, I'm just going to type in, I'll just copy it in. I think I can copy and paste this in. But we give it a little bit of JSON text. So each one of these commands is a JSON object, and we're giving it this message ID saying to do something or other. And I think this is, we are requesting a token to use later. I don't know why you need this token, but you just need it. So you give it 0 to begin with, and then it will give you a token. So I'm just going to paste that stuff in there and hit enter. and we'll see that the server replied to us with another little piece of JSON. So it's given the return value of 0, which I think means success. Message ID is 257, parameter is 1, model is blah blah blah. So there's a few things, information in there, but this param1, this is the token that we're going to need to use later. So that's the important point. So now that we've got that token, we can give it another message, and this time it's going to be message ID 769, and instead of token 0, I'm going to put whatever it told me the token was just now, which was 1. So I'll just type that in there and copy it there, and paste that. Now this should cause it to take a photo. There we go. So you probably just saw the screen flicker a little bit, but you must have heard it beep, I hope. And it's also given us a bunch of information here about the photo. You know, it's a type, it's a photo taken, blah blah. This is the file inside the camera somewhere that it's stored it, I guess. And right at the end here we get this message ID 7, type battery param 87. I think this is just telling us that the battery is 87% full still. And I've noticed that if you sit here, oh damn it, we just missed it. Did you see that? This one came in without me doing anything. Now it's 86% full. So this message comes even if you don't ask for it. The camera will continuously feed you this message when the battery percentage changes. Okay, now let's have a look at how we can get the Arduino to do what we just did in Telnet. I'm calling this an Arduino. It's not really an Arduino, but the Arduino IDE has some sort of plugins or support for this that lets you use the Arduino IDE to do stuff as if it was an Arduino. So that's why I'm calling it that. Here's my sketch here. We'll look at that in a second, but I found that I could not get this to work without upgrading my Arduino IDE. I was using a pretty old version, 1.0.5 I think before, and I couldn't do any of this stuff with it, so I've upgraded to 1.8.1, which I think is the most recent one at the moment, and that has some pretty neat stuff in it, in that it lets you automatically download support for more development boards within the IDE. So I'll put a link in the description to some info about this, but basically what you need to do is come into preferences and paste in this URL here, which is a reference to some specific stuff that will give you support for the 8266. And after you've done that, you can come down here and you can see I've got Wemos D1 in there already, but originally that was not there. But then you can come into Boards Manager and see at the bottom there it's getting some info from the internet, and then I have a big list of extra boards that I can add support for to my Arduino IDE. Well, actually this one's already installed, as you can see there. But in here you would search for ESP8266, and there it is there. And then, well, if it was not installed, I think this button would say install. Oh, there's an install button there. And you can get different versions of that API or whatever you would call it. And then you should be ready to go. It's very, very easy. And then you'll see that this one will show up here. So I've selected that as the board to use. Yes, CPU frequency is 80 meg. Isn't that nice? Flash size is 4 meg by the looks of it. Oh, okay. And that's the port. So anyway, let's look at the sketch. I won't go into too much detail of this because I didn't write most of it. I just sort of rearranged it a little bit to format that I liked. Oh, speaking of that, we should pay a little bit of credit to this guy here, because this is where I got this sketch from. Emmanuel Nutella, oh no, Granola, no, what is it? Granatello, oh yeah. And this link here is where I found this sketch, and I got excited when I saw his videos that he showed here where it works quite nicely. This is using the original Xiaomi Yi there. and these people are quite thankful too by the looks of it. So back here, basically there's a few steps. We need to first try and find the network ID. Not sure what this stands for actually, but it's something ID, I think it is. And we need to know the name of the network, but we know that any network set up by one of these Xiaomi Yi cameras is going to start with YDXJ underbar, and in the case of mine it was so it'll be something like this, YDXJ underbar 117, probably just a big number after that. So we need to find that one. That's what this function does. And once we've found the name of the network, we pass that name to this function, which is actually going to connect to the camera. Connect. This should really say connect a network, I think. That would be a little bit more appropriate. Oh, whatever. The camera is on the network, and the network is on the camera, whatever. So that is going to then attempt to connect to that Wi-Fi network using the password there. So obviously if you've set a different password on your Xiaomi Yi, you're going to have to change this bit there. And this will retry 10 times with a half a second delay in between. I don't think it has ever failed in my experience. Usually just works straight away. So once that has succeeded, then we try to request a token, and this is sending that little piece of JSON that we looked at before, message ID 257 token 0. And then we delay for 1 second to let the server process that. But as you saw, it was pretty damn quick, so you probably don't need to wait that long. And then we read in all of the text that it gave us, and then we search through that for the string double quote param double quote colon. I've just closed the window that we were looking at before, but hopefully you can remember what we saw there. It was a piece of JSON that had param in it. So if we don't find that, we fail. Otherwise we continue and we look for the following little bit of text. So from that offset plus the length of this param itself, we're going to read in all of the characters following it until we hit either a comma or a space or the end of the JSON object, which is a curly brace like that. And so that's going to find the token that we need to use. In most cases it's just going to be a simple number like 1, 2 or 3. It just counts up from what I've seen. The first time we try it will be 1 like it was just before when we tried it. Next time it will be 2 and then 3 and so on. I don't think it's very complicated. It's not like a secret encryption sort of thing or anything like that. Clear incoming is just a function I made to wipe away anything that the server sent to us. I don't know if it's going to fill up an input buffer on this microcontroller or what, but I thought it might be safe just to clear out anything that's coming in from the server. And then this is the function that will actually cause the camera to trigger a photo. So I just clear away anything that the server might have sent us. For example, we might have some of those battery status messages coming that we don't really want to have cluttering up our buffers. So that will get rid of those. And then we send the 769 message, which is to take a photo. And we put our token, whatever that was, inside the second part of the JSON there. And we have to send it a new line and a carriage return by the looks of it. Anyway, so those are the functions that deal with the camera, and then to put those all together we have a setup function which just starts up a serial connection so that we can output something to the serial monitor and have a look at it as it's progressing. And then we have this loop which is just going to go over and over, and it tries to, if we don't have a connection, it tries to get one. Otherwise, if we do have a connection and a certain amount of time has passed since the last time we took a photo, then it's going to take a photo, basically. So it's just going to take photos forever, and the time I've set here is 4 seconds. I found that the camera is a little bit slow to take photos. If I set it to less than 4 seconds, it sort of has a bit of trouble keeping up. So I thought to be safe I'd leave it at 4 seconds, and yeah, this is not what I'll be doing when I put it on my quadcopter, although you could actually just do this and say make every 5 seconds take a photo. That might be good enough, come to think of it. If you didn't want to bother with the GPS module, you could do that. Yeah, so that's about all there is to it. So let me upload this. I have my Xiaomi Yi camera is still on and it's ready and waiting to do this. But let's see if we can get this on the view again, just so that you can see that. See it there and hear it beep when it takes a photo. Right, so I'm going to upload this sketch and then we'll look at the serial monitor. It did not work. There's a bit of trouble uploading sometimes. Port has changed. Okay. Alright, there we go, it's uploading. So now let's look at the serial monitor. There we go. So it's just going to take photos forever, every 4 seconds. There's 2 beeps per photo, by the way. I'm not sure why that is. It's sort of like 1 beep immediately as it takes the photo, and then maybe another beep as it finishes saving the file or something, because I've set it to 4K photos. That's 12 megapixel photos. They're pretty big files. So I think it's just the second beep takes a while because it's a big file to write to the SD card. I don't really know, but it's probably what it is. So yeah, it's just going to sit there taking photos forever until I disconnect this and then it will stop. So now I have another sketch ready to make this work with my GPS, so that every 20 meters it's going to take a photo. I have not tested that yet, so I'm going to test that tomorrow when it gets light. Okay, I'm just doing a little walking test here, and I've put the components on a piece of foam board just to hold them all together a little bit more conveniently, and powering it from a USB power bank that's in my pocket. And I'll just turn that on, and I've set this up so that the blue LED is giving us some indication of what's happening. It's quite slow at the moment because it's continuously trying to connect to the Wi-Fi network on the camera, which is off. So let's turn that on, and then it will get a bit faster. And when it also has GPS lock, as we can see by the red LED on the GPS module, this blue flashing will get quite fast, about 10 times a second or so. Okay, looks like we've got GPS lock now. Okay, there we go. So when both of them, the GPS fix and the wireless, the Wi-Fi are available, it will do this fast flashing layer like that. And it has not taken any photos because we haven't moved anywhere, because it doesn't need to. But when we move, we should hear it beep as it takes a photo. It's set for 10 meters. So that's 10 meters. And if I stop, it'll be the same again, no photos. So it's working quite nicely. I had a few little problems along the way, mainly differences between this camera and the older camera. The older camera seems to be quite a bit slower to start up, so I had to put in a delay for 2 seconds when it was trying to connect to the camera, to the server, and also retry 30 times instead of 10 times to connect. So just a few longer delays and things like that were necessary to make the older Xiaomi Yi, the original one, work correctly. And with this one, I've found that if I reset the Arduino, sometimes it can't recover the connection again until I turn this camera off and then turn it on again. So that's a bit of a bummer too, but if anybody is trying these, if anybody tries this sketch out, you might find that you need to turn the camera off and on again to get the connection to re-establish. It's a bit finicky, I admit, but I have actually done a flight this morning. I did a flight over here, over this area, I'll show you in a minute, and everything worked okay. So, yeah, I think that's about all I needed to demonstrate. So just to have a closer look at what I was doing there, it's just an SD card reader writer, GPS module, and then the ESP8266 there, and I've just connected them up so that they're all connected to this here, which I'm going to plug onto my hexacopter flight controller board to get 5 volts supply from. And obviously the sketch that was running on here that we were just looking at is not the one that we went over in detail just before that. It's quite a bit more complicated sketch. Well, it's not really. There's more stuff in it, so you have to run the SD card and the GPS. It's not too difficult. I've covered this sort of thing in my other videos in the past, so I'm not going to go into details of this particular sketch, but I will put a link to it in the description. So I stuck that onto my hexacopter, and I used my Survey Flight Path Planner tool to generate this flight path. According to Drone Deploy, it's about 4.5 hectares of area, and it took about somewhere between 7 and 8 minutes to fly. I think I set it to go at 6 meters per second or so speed. Probably could go a little bit slower and a little bit higher. The altitude I set to 20 meters and just stayed on the same altitude the whole way across. Here are some of the images that were captured, and as you can see, there's not really that much overlap. It's about 50%, I think. Really should be a lot more than this. I think they recommend 80% overlap as a good number. This is probably a better way to visualize the overlap. I just sort of shrunk some of these images down and just roughly positioned them by hand to where it looked like they matched up. So now you can see that it is, like the top of this image is about the bottom of this one, so it's almost exactly 50% overlap. And here's a little bit more. That's the second pass, I guess you could say. So again, it's about 50% overlap in that direction as well. To get the georeferencing data embedded into the images, I had to write a program to do that, and I'm definitely not going to be explaining that one because it was quite tricky, quite a bit of trial and error, but I will upload the source code for that and also a build for Linux 64-bit, but I'll just show you quickly how it works. So the SD card will have this file on it, or a file like this, and it's just going to have a list of the GPS locations at which each photo was taken, and that should match up with the number of photos that you have on your SD card. And then this is my source code for my program, and then this is the program here that I'm just about to run, and you run it by you just give it the folder to process, and the folder should contain the images along with this data file like we see over there. So like that, and then it will output these other JPEG files called out, and these ones, if you look at these, well, that's pretty big, you should see in the EXIF data here, we should see the GPS information there. I think this program that I'm using here, it's called, what is this called? It's called Eye of Mate. It's quite a good program, but I think it has a bug here because it's not showing the latitude values, it's only showing longitude and altitude. And my program is hard coding the altitude to 20 meters, by the way, so if you need to change that, well, I guess you're going to have to compile the program yourself. But yeah, if you wanted to do this a different way, there's also a tool on Linux called EXIF tool, which is pretty useful. And if you give that a -a command or parameter with one of these files, it will print out all the information there. So this one does not have a bug because we can see it's actually showing us the latitude properly, and it also gives you it all in one line if you wanted to check it like that. 20 meters above sea level, so everything looks good. So these files can then be uploaded to Drone Deploy. When you first upload your photos to Drone Deploy, you should see this nice display here, which gives you an idea of the overall area that you covered and the locations at which your photos were taken, so that you can just make sure that it's what you expected instead of something crazy. And as you can see here, going down the straights, it's given me a very nice sort of almost like a grid-like spacing, because the width between these passes is 20 meters, and the distance that I set to take the photos at was also 20 meters. So you can see, like right here, it's almost a square, and another square, and a square. So I was quite pleased to see that. And at the end, of course, we get a bit messy because it's turning around and stuff. But overall, I was quite happy with how it turned out. And here's the final result after processing on Drone Deploy. It took about maybe 4.5 hours to process this. It was 115 photos in total, and it came out very good. I thought it was very good, considering that it was only 50% overlap. So of course I'll be trying this a bit more in future and experimenting with heights and speeds and everything. Feeds and speeds, here we are again. But it's done a very good job. It was mostly overcast, but there were some breaks in the clouds every now and then. You can see this bit here. I think this sort of yellowy area is where the sun came out. You can see the shadows are a bit stronger there than they are over here. Just let that load in a bit. It's a little bit slow. Oh, there we go. Yeah, anyway, so there's a limit. I'm just using the free trial of Drone Deploy at the moment, and there's a limit on how much resolution they'll let you do with the free stuff. So I think this is a maximum of 3 centimeters per pixel or something. But it's looks really good. Pretty decent amount of detail, I think. So we can see this old milking shed here, which is obviously not in use anymore. It's all sort of overgrown. Reminds me of the city of New York in the I Am Legend movie, with all the grass growing up through it. So I'll just have a little look at this. I think I've pretty much said all I need to say for this video now. And we can see that it all works reasonably well. Here's another abandoned building. Yep, pretty decent detail. Yeah, so considering that it was only 50% overlap, it's done a remarkable job, I think. And here's my place. We should look at this in 3D in a minute too, so we can see how well it has actually done generating 3D map of this too, because I think some people may be interested in that. Didn't do very well on the trees in 3D, but the rest of it, it did quite well. Another abandoned building, although this one hasn't fallen over yet. I'm living on the abandoned side of this farm, I think. Another one, maybe? Alright, so let's have a look at the 3D model. Oh, might have to fast forward this. Okay, that has loaded now. I don't really like this viewer very much because you can't rotate it around where your current viewpoint is. So if I zoom in here and I rotate, it's just the center of rotation is some wacky place. But anyway, we can see that it has done a fairly decent job of detecting the 3D structures and giving them walls. There's a fence there. Nice roundy walls on this water tank. And if you come over here, yeah, it's a bit awkward to get around in. This building looks quite flat, and that's because it is actually flat. It's like almost completely fallen down so that the roof is pretty much on the ground. So this is correct, believe it or not. Oh, God. They really need to give you a different way of navigating this, I think. This one didn't turn out that great. It's all sort of jagged on the walls. That little one's okay. There's a creek there, so we can see that it actually, the ground goes down into the creek. It actually looks pretty good considering it's right on the edge of the photos. This tree didn't turn out very well. This tree is flat as a pancake, which didn't turn out very well. This one here, that is. But the house and everything around it did pretty well, considering again this is only a 50% overlap. And there's a water tank again, garage, oops, car. Yeah, I think it did fairly well. This is incorrect, but most of it, the rest of it seems pretty accurate. Managed to find this little, what do you call it, little eaves or gables or whatever, roof things, quite small, but it managed to pick it out. And car is not too bad. Oh, seems like the more you zoom in, the worse it gets, but that's not bad. So I'd be interested to see how well it can do with a really good 80% overlap of photos, which I'll try next in a slower flight path as well. I even noticed that this here, there is a broken old bathtub out in the field. I don't know why. Got to have one of these on your farm, don't you? Every good farm should have a broken bathtub. There's actually 2 around my place, but anyway, the point is that it's detected the walls of this bathtub, which is only a very, very small thing, and it would have only had, I think, 3 or 4 photos at most to do this with, so it's really quite impressive the way it manages to do it. What about this bathtub? Oh, it's kind of given some 3D structure to this one too. Look at that! Oh, it did too. So this is another bathtub. I don't know why there's bathtubs everywhere here, but there it is, and it's given it some 3D structure as well. Actually, that reminds me. I think there's another one somewhere. I don't know what it is with this place in bathtubs, but look. There's another one here. What do they use these for? Why are they just... See, I can't navigate very well to look at this one properly. But it looks like it has some 3D structure as well. Just maybe not quite as good as the others. Well, it's pretty good, yeah. Anyway, I'm just rambling now, so I'll leave it here, and you can maybe try those sketches if anybody wants to do this as well. Let me know how it goes, and thanks for watching.